In this video, we'll talk about graphing quadratics. So first, I'll give you an exercise where you already have the graph and you just have to find out the equation. And in the second exercise, you will be given the equation and you have to draw the graph. Now, when determining the equation for a parabola, you have two options. So you can determine the equation based on your minimum or maximum point, which would be at 1 and -2. So here's 1 and -2. Or you can determine them based on your intersection points with the x-axis, so the x-intercept. But here in this case, you can see that the x-intercept is not very clearly defined. It can be somewhere in between, but you don't know if it's exactly in the middle or somewhere on the side. So we'll use the minimum point in the first example. In the second example, you can see that the intersection here is at 1 and 0 and 4 and 0. So it's much easier to use the x-intercept than to use the maximum point here, because that can be somewhere over here, but we are not sure where exactly. So let's start with the first method. The first method, you might have seen that kind of equation before, looks something like this. So you have y equals to a x plus b all squared plus c. And there's also a second option where you write a minus in front of this. That's actually the easier way if there's a minus. But let's just stick with the plus for now. So in this case, a is the factor by which the parabola is stretched. So if, for example, a was 2, your parabola might look something like this, a little thinner. If it was 1/2, it would be more open. But in this case, your a is just 1. Because you have here the intersection at point 1. If you go 1 to the left and 1 up, there's the next intersection, which means 1 squared is just 1, so there is no factor. If, for example, we had 1 squared is 1 and then times it by a factor of 2, we would just meet the y-axis over here. So a is 1. It's also positive, so here's just +1 pretty much, because the parabola is open at the top. If the parabola was facing downwards, like the second option, you have to put a minus in front. So next we'll go to the b. The b you can find out by how much you have to shift the parabola on the horizontal axis. So you can see there's a shift of 1 to the right. Now the question is, do we put a 1 or a -1? And I'll already tell you the answer and have to explain why we have to put -1 in this formula. So the reason for that is, if you plug in 1 for x now, you will get 0 here, and you just end up at y equals to c. So if we plug in 1 for the x-coordinate, we should end up at this point, which is our c. Because if you put here +1, let's just use the hypothetical. If we put +1 and we plug in 1, we will get 1 plus 1 is 2, squared is 4, So then we would have y equals to 4 plus c has to be -2. But that wouldn't be true, because we have to end up at c equals -2. So we need a negative. Just remember that anytime you do a shift to the right, you have a negative. If you do a shift to the left, you have a positive. So now the c is just the vertical shift, and the whole parabola is shifted 2 downwards. So that means c is equal to -2. So our final formula here looks like this. Alright, let's do the second one. In this one we can use the points of intersection, which are 1 and 4. So for quadratic equations, you might already know if you solve them. You can just plug in this number in that form. Y equals to x minus, now the first intersection point, which is 1, and x minus the second intersection point, which is 4. And now the last step, that's not the whole answer yet. Last step is that because this parabola is facing downwards, we also need a minus in front. Now if you want to clean it up, you can also multiply the minus into those parentheses. Just use the second one. So minus times x minus 4 is just minus x plus 4, which you can also rewrite as 4 minus x. So that's our final version for this graph. Now let's look at the next one. For this one again, we need the maximum point over here, which is at 1, -2. So that already looks like the one we did earlier, which is true. It's actually exactly the same, except now the parabola is facing downwards. So we have to add a negative in front. So it'll be minus, and then x minus 1, because we shifted the parabola to the right, all squared, and then minus 2, because we shifted it down on the vertical axis by 2. And that's your final form. And now for the last one, we'll use these points, intersection again. But now y is equal to x minus 1 times, because here 1 and 0, and 4 and 0, so x minus 4 for the second one. And those are your final answers. Alright, let's go to the next exercise. This one we will look at the equation and try to draw a graph. So if you want, just pause the video right here and try to graph these by yourself. So the first one we'll do based on the intersections, or the x-intercept. So here, what does x have to be for this whole term to be 0? Because if we want, I forgot the y here. So if y is 0, which means it's somewhere on the x-axis, what does x have to be? Well, if we plug in 1 for x, this term here will be 0, and 0 times something is 0. So at 1, we will have y equals 0. And if we plug in 2 for x, this term will be 0, so then y is also 0. So at 2, we've got another intercept. And now there's no negative in front, which means the parabola is facing up. And it will just look something like this. that's our final parabola. Not the prettiest one. I'm sure you can do better, but that's just a rough draft here. Alright, let's do the next one. This one we have to actually change the forms, so you have two options now. One option is to write it in the first form with intersects. So x plus 1 times x plus 4. And if you want to test if that's actually the same, just calculate it out. X times x is x squared. X times 4 is 4x. 1 times x is x. So 4x plus 1x is 5x. And then 1 times 4 is 4. So that will be the same. And your other option is completing the square. Although that would be a little bit harder. So let's just stick with this method for now. So the first intersection is here at -1, and the second one will be at -4. So 2, 3, 4. -4. And because we also don't have a negative in front, again, this will be facing upwards, and will look something like this. That's our final parabola for number 2. And now number 3, we already have the final form, just have to draw it now. There's a minus, which means the parabola will be facing, or will be open on the bottom. And then -2 means there's a shift of 2 to the right, because if we plug in 2 for x, this term will be 0. So shift of 2 to the right after a shift of 1 upwards. And now just draw it downward. It will look something like this. And that's our final answer for the third exercise. If you need more practice questions, just let me know and I can provide you with some and also show you the answers for those.